Hello, welcome to another Onshape design session live stream. This is episode 7 of the Stinger 1.5 robot redesign. And I do believe we are looking at the home stretch. I do believe this will be the final push to get this thing wrapped up and get it on the 3D printer hopefully very soon and get it back functional. So welcome. Again, this series, the whole point is partly for me to kind of put Onshape through its paces because it's fairly new to me. Been a SolidWorks user for a long time. Partly to be somewhat hopefully entertaining. Hopefully somebody finds this useful. That the educational aspect is quite accidental, I assure you. But yeah, we will go ahead and hop right into Onshape. So we have officially, as of the last episode, last week's stream, got basically everything put into place. Everything we need is now here. All of our fasteners, most of which were taken from McMaster Carr. I'm missing two. I noticed that now. We're missing a couple in the wheels. So we'll have to take a look. Get screws in there just so that we can get a complete bill of materials. Throw a battery in here too. Again, just for purposes of bill of material. Maybe also weight. We'll take a look and see if there's a weight that we can just... I do believe rather than assigning a material, it's possible in Onshape just to sort of force a thing to be a weight. Usually 3D CAD uses a density from the material, but in the case of the battery, like I'm not going to be able to accurately model all the exact materials in the right proportions. So probably the same with these boards and things. We should be able to assign a material to the chassis, the main 3D printed body piece here, and get a pretty good weight off of that, just off of density. So sort of on the docket is to make sure that we've got a place for all of our wires to go. That's sort of up first. We need a place for all the wires to go. So on these guys here, I'm thinking we need a cutout in the chassis to sort of stuff them back behind, because they'll be connected sort of across using these JST connectors. We need a way, something that looks somewhat planned, like we meant it to be there, in order to get them up and through and to these connectors here. We only need one. It's going to sort of, so it feeds in from, these are the VLX, so from this JST port, we'll need to get some way to get a wire down to this port, and then these just daisy chain together, and there's no return wire on this side. So, yes, and then the other thing we need is to get the wire out of this LED array and to the NeoPixel port here. That is the plan. So I think what has to happen, let's plan for those wires first, because I think those will be the easiest. That sort of cutout here, that's going to be a little tricky, and quite frankly tricky I don't want to deal with 2 minutes into the stream. So I think first, I need to change this shape. I think I'm going to square it off so that I can cut in a channel. One, I got to get wires out of here, or at least I have to get a recess in here so that I can run a channel, at least a little bit of a channel, similar to what we did back here. So if we look, there's a shelf on this end, and that shelf on this end of the LED array, there's a shelf that is meant to allow the wires, once they're soldered onto the back of the LED array, we need some room for the wires. So we need a shelf similar to that, a channel, and we can really just go the whole width. But to do that, I kind of got to get rid of these little cutouts, and I don't need the same thing over here because, again, like the sensors underneath, the LED arrays will be daisy chained. So out of this NeoPixel port, in here, out of here, out the back. This one goes out the back through these channels that we did last week. I'm thinking to pigtail them and just sort of pigtail together so that I can pretty easily feed wires through. Yeah, so let's go ahead and get rid of that. Let's start there. Let's start there, not get too ahead of ourselves, and then get rid of these guys. And first, I have to remember what they are. I don't remember what those features are. I don't think it was in the main extrude. Let's check. First, we need to just select the sketch. Let's edit. Okay, they're not. I added those when we did the motor, I think. So this sketch, edit. Now the tricky part here is going to be when I just plain delete these, hopefully I didn't, let's go for a clean top view and do a horizontal constraint. Hopefully I didn't dimension anything off of that point. Because that, at this point in a design, has a real possibility to blow stuff up in not fun ways. Everything can be fixed, but let's hope. I'm going to do that. So I did have something dimensioned here. What? The plane? Ouch. Ouch. The plane, I think, is what was plane 1. Where is plane 1? It's in NeoPixel. The mirror broke. That's okay. I'll fix it. That's fine. Plane 1. Yes, I dimensioned that off of a point that no longer exists. Ooh, that's a problem. Let's see. I'm pretty sure. Where'd it go? Where'd you go? I lost it. Plane 1, NeoPixel Poxit. So that I expected to kind of break. Sort of I expected the plane to break too. Or, well, I couldn't honestly remember. So offset from that face. Okay, that is the pocket we created. That's the pocket that goes all the way out the back. So what about this? That sketch that defines the actual pocket. Where did I dimension it? I dimensioned it 15 thousandths off of that point. All right, so best thing to do is going to be, I'm going to undo my change. I'm going to figure out where, I mean, in reality, where this is probably off of, I mean, 0 is in the middle. I don't, as we're modeling, I mean, I'm okay dimensioning off of 0, even though it's in the middle. It's kind of in the middle of nowhere, really. Dimensioning off of this front edge is probably better. Let's go off of 0, because then if I move the front edge, it won't hurt anything. The origin's not going to move at this point. So I want to get a dimension. I just want to know where this is. And that is in Y, so we'll check our measurements Y, 1.037. That seems like it might want to be metric. Let's try it. Millimeters. Nope. Okay. Inches, 1.037. All right, so we're going to kind of guess, because this corner, I think we dimensioned coincident with this corner. So I'm just going to call it an inch. That should move it a little further back, and we've got real estate toward the back. I'm just going to call it an inch. And I'm going to redefine this sketch. It should be this one. Edit. And I dimensioned somewhere is a coincident. There, is it that? Nope. Is it that? Nope. What do we got? What do we got? We got a parallel. A coincident. I want to see. Show me my relations. Show me my relations. I don't remember what I made coincident. That's coincident because it's a rectangle. Ah, there it was. And there it went. It disappeared. Which one of these is the culprit? I don't want to just delete that line. Okay. I don't want to just delete that line. That's the thing. And I keep, is there a way to just show relations? Can I do that? Can I just right click and show relations? Is there some way? No, I don't have many options up on the toolbar either. What if I right click? Can I just show all? No. What if I undo that? Can I? Yes. Okay. that showed an awful lot of stuff all at once. We didn't want to do that. So I guess I mean, that's kind of, honestly, that's kind of clunky. Not being able to get back to a relationship I need. Like, that is, it is related off that point. Like, and you're not going to let me select the point itself. That's kind of frustrating. What if I delete this dimension for now? If I just delete it. No, that didn't help. That dimension, why did it, that dimension is dimensioning my outer bound, not my, I'm wondering why this construction line here is floating now. Oh, because I gapped it at the top. I bet. So let's add the dimension back in. I guess I'm just stuck floating my cursor around trying to find... Is that it? No, that's a horizontal. That's a coincidence. But that's those two. I had it there for a second. It was there. I saw it light up that point. I don't know... Why won't you just show me the relationships? Select parallel. I don't want to do that. Curves, hide all, hide other. Construction, transform, copy, confirm. Show constraints. Look at you. It is up here in our thing. All right. So one of that guy right there, delete it. Right. Whole thing floats. Whole thing floats. Now let's move that pocket. What did I say? 1 inch off of 0. 1 inch even. So that constraint is now gone. That was the only thing, I think, that blew us up. So now if I go here to the motors, let's minimize that. If I go back up to the motors, and I don't remember which sketch we were working on there that created those wings. That right there, edit. Now if I delete and go back through the motions, make this horizontal, oops, no control click. SolidWorks workflow sneaking in, just click, no control click. And then draw a line to make that just a rectangle. I don't want to delete the other lines in case there are other relations. If I do that and accept it, we did not blow anything up. There's nothing red, everything is happy. Awesome. Now, that is now a complete rectangle. Let's go back to our assembly and take a peek at what we've got to do here. I think pocket first. This pocket, I probably want to define the plane because I think I created the plane and basically cut backwards. So I need to figure out where I defined that plane. I think I defined it to the pocket. Let's go back and grab plane 1. I've noticed again, every criticism I've had of Onshape has been like minor nuisance type stuff. All right, so how did I define you? Edit. I defined you as a 1/4 inch off the end of the cutout for the board. So I'm going to do the same thing on the other side. A 1/4 inch off. I believe this was 75 thousandths deep. 70 thousandths deep. So 1/4 inch off the end of this cut, which would be this face here. I need a plane. Where's my plane icon? Which one? That one. Offset distance 0.25. Okay. That's good. And then on that plane, so I was saying that the complaint I have right at the moment is how hard it is to select planes that are sort of in the middle of stuff, because I should just be able to highlight here and get it, but it doesn't like me that way. That would be, preferable, but like I said, minor complaint. I do want a front view so that I'm looking right at it. We want a rectangle We're going to make said rectangle 70 thousandths tall, and then I'm going to constrain it to the bottom and the sides, 0.07, and then we'll have to figure out how long, like how far to cut out. So there's that. Can I set you on that? Oops, select the line. Can I set you on that? I should be able to do a coincident. Okay, let's check the front. That looks at the right height. And can I set you to be coincident? I cannot. All right, so you don't like that. You don't like that for coincident. Well, that's unfortunate. Vertical, maybe? Nope, you don't like that either. What about I grab the whole line? Or what if I put it on the surface? I mean, it worked once. It worked on this surface. So what if I do that? Surface coincident. How about that? That I like. And then we're the full width. We're the full width with only defining one dimension, the depth, which is good. So that's 70 thousandths deep. How long? We've probably, I mean, my sort of gut instinct is to make it, is to basically double this. So this is a 1/4 inch to the plane, go a half. I think, though, I want to do something tricksy, like maybe do a nice swooping up type radius. If I come up a half, is that going to do... If I come up a half, is that going to do what I want to do? Yeah, I think so. I think so. I think so. A nice swooping up radius on the end when we're done. So I will... A couple of ways I could do that. I'm going to accept, grab that sketch, extrude, and remove material. Crap, it cannot be on that. It's got to be on the top surface. Important note, edit. Because it was going to dig a channel. I don't want to dig a channel because this material still exists. So I need to edit that. I need to get rid of the coincident constraint there. Change it to be coincident here. And then the 70 thousandths is going to have to change. Delete. Come down here. Can I dimension now to that surface is going to be the question. Because it's I really could not care less what the overall height of that is. I want it to be 70 thousandths from here. And that'll work. That was easy. 70 thousandths deep still. Now it'll remove all my material. Now if I grab it and make it a 1/2 inch and 0.5 and remove, now we get a pocket. That'll remove that top surface too. Cool for the wires. Now I want to create a cut that basically goes across this way. And I'm going to do, I think, a fancy looking S-bend. I could, and this was the first thought I had, was just, where's my fillet command? Was just throw a fillet in there. I don't know how big, but, you know, something like that. Which actually, I mean, obviously I would have to go way deeper than a 1/2 inch to make that work, but that actually doesn't look terrible. I think I like, do I like that or do I like the fanciness of the S-bend? I mean, we're 3D printing. Part of the goal of this entire project is to make it pretty. And to a certain extent, fancy equals pretty. We want to be, it's a balancing act in my head as a designer. We want to be fancy, but we also want to be manufacturable. I want to end up with something we can actually make. In this case, I don't see any risk to making this fancy in a way that it cannot be built, cannot be printed. So what I want to do is I'm going to cut an S bend. So I'll start with a fillet and end with a fillet and make a nice S transition type thing. And I'm going to do that, I think, on this plane and then cut the other way. That, I mean, seems reasonable anyway. It's really 50-50. Doesn't really make much of a difference how that gets done. But I want that point. I want an arc. Right now, the key is probably just to make sure it's not bending this way. We want it to bend down. That may have thrown a tangent constraint in place. SolidWorks would have. I don't know yet here if Onshape did. But again, the key for this kind of a cut that I want to make is just to make sure the curves are going the right way, because I can always, okay, it did. There's my, it implied tangency. If they're bending, curving in the wrong direction, that is a much harder problem to deal with. I want to set those two curves tangent. That makes a nice S-bend. I'm going to set them equal. They don't necessarily need to be, but, I mean, why not? So they're equal. Now they have an equal radius. So we're tangent down here. I want to also go tangent on the top. Tangent. Now, there is a risk that is coming up that I need to close this, right? And in order to do this properly, this and this need to be vertical, like the center of this. That way I never curve too far down. This point. Well, actually, I don't need to be vertical. Let's undo that. I need this point rather. The important part is that this point is on this surface, which I should be able to do a coincident again. We'll just make sure. That way I can't like grab this point and make a big circle, right? That's what I'm, trying to avoid. But I need to close this in order to do a cut, and I'm going to do that with a line to this corner and down to my point. So the curves are floating, which is okay, and I can, draw that out as far as I want, really. Actually, probably just define the overall length of this top line. Will you let me? That would be cool. There we go. What's it look like at a 1/2 inch? Let's start there. That doesn't look horrible. There might be a problem when I go to cut, because if you think about geometry and sort of think under the hood of what's going on here, there's like an infinitely small slice of material here. It's very, 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 very tiny. Infinite is almost a truly correct word to describe how small there's a slice of material in here. Sometimes, I know SolidWorks at least would freak out over that. But let's see what this does. So I want to do that. I want to remove. It would, okay, it's going to freak, and that might be why it's red right now, but we'll see. I don't want it blind. I want it up to a face, and the face I want is this one. Okay. I mean, it's happy. I don't know why it was red in the other direction. It's happy, right? Because like I said, if we zoom way in, look how tiny that gets. And sometimes with tangencies and really, really small slivers, SolidWorks would just flip out. But that gives us a nice, smooth transition. That gives us a chance. And actually, did I just do that all? Did I do every bit of that on the wrong side? Yes, I did. Every single bit of it. Well, welcome to live designing. Every bit of that now gets to get deleted. And I get to do it over here on this side. Fantastic. On the bright side, I should be able to redo that fairly quickly, but man, I hate it when that happens. Literally, there's no, I mean, the plane is savable. Everything else is not. So I might as well just delete it all. The plane is savable because this is the side with the plug. So the cord's coming out of this one, like it's coming out of the board into this side and out and around, and there is no out on this side, right? This just stays the way it looks. Okay. We need a plane, 1/4 inch off of that plane, off of that face, offset 0.25 inches. Okay. We need a rectangle on said plane. Give me the plane. So that's a little annoying. Selecting that way is a little annoying. But we need a rectangle. Sketch rectangle here. So here we go. So you are coincident with that top now. No control. I keep hitting control click. SolidWorks workflow, right? You need to control click. Here you do not. Just click things. This line on this face, this line on this face, and then 70 thousandths from here to here. 0.07. Awesome. Awesome, awesome. And I went 1/2 inch on the cut, extrude, remove 0.25 inches. Oh, 0.5, 1/2 inch. right? 1/2 inch on the cut. There we go. And now we need our S cut. Same thing. Sketch, redo everything that we just did, except do it right. So there we go. There's that. There's that. Again, make sure they're bending the same way. That's really the crucial part. That needs to be on this surface, coincident with the surface. This needs to be tangent with the surface. Right? That's sort of, again, as sure as I can't go sort of nuts with. Now, did we get an implied? We did get an implied tangency. We did not. Did we get it? We did get a tangency between the two. Right? Tangency between the two. I want to see it. I think maybe not. Just to make sure, let's click it. Doesn't hurt. Let's click it and make them tangent. There we go. It was not tangent. That point moved ever so slightly. And again, we don't have to set them equal. They don't have to be. I am going to set them equal. Just for symmetry's sake. I need to close that in again. There to that corner, straight down. And then I set that whole thing to 1/2 inch long, 0.5. And actually, that might work in our favor. That might work in our favor because I'm thinking, so this is where that other under sensor is, and I got to get a cord up, and I don't really want to go all the way out. I'd like to cut out material to pass a cord through. I can't do it inside this pocket because the PCB is there, the main board. And the main board is kind of inviolate, like I can't pass material through it. I'd have to cut through it. I don't want to do that. I didn't plan, I mean, it's possible to plan ahead and just put a hole in the PCB. I didn't do that though. The PCB is exactly as you see it here. In fact, I soldered the various connectors onto it today. I did film that, and I even did a cool time lapse of it. However, I'm probably even worse at that sort of video than I am at live streaming. Hi. And I'm not sure how much of it is usable. Like, it's okay. I was out of focus. I had the wrong part of the frame. You know, I wasn't working in camera most of the time. It was awesome. And I used my phone, so on the like hyperlapse setting, so a like 1.5 hour worth. Okay, it does not like that. Why don't you like that? I need to remove. That's why you don't like that. That's why you don't like that. So like 1.5 hours of soldering was a whopping like 3 minutes of time-lapse video. So, I mean, I'm not sure if even editing can stretch that out into something useful. We'll see, though. I did also, while I was doing it, screw up the power board. Or not the power board, the motor driver. So a motor driver board goes here. Except this right here is, if I were, I'm not going to, but if I were to open the circuit diagram, is designed to take the driver board straight down, or with the top of the board facing up. I soldered the male pins into it upside down. So the pins are pointed up, which means it would be upside down in these sockets, which means the pins don't go to the right spot. And I think I'm just going to order another one because they're only like $5, and it is a pain trying to desolder 6 and 8 pin connectors, get the holes opened up so that I can resolder them. Kind of a pain. I think I might just order another board and call it a loss, and just solder them on the right way. But we're here. We're here now. I need to come up through here with a cord that fits in here, right? A 4-wire pin, a 4-wire cord. And I think a cool way to do that might be to just literally, I mean, I'm going to measure, I think I'm going to measure, I don't know why it snaps the zooms like that too. I'm not doing anything different than I did. Like, all I did was let go of my wheel on that one. As I was zooming in and out, I let go. That's it. Like, let go and it does it. Spin, let go and it does it. I don't quite get why. Is it because I'm out in space? Let's test it. No. Is it because I'm on the part? Maybe because I'm spinning it on the part. That seems to be it. Out in space, no zoom. On the part, zoom. Okay. Good to know. Good to know. Yep. Okay. I got it. And it's probably going to keep doing it because that's a habit. So the female connector that, or male connector that mates into this is pretty much within the bounds of this white plastic. So I'm thinking, without actually having one of those cables in front of me, like I don't, right? I'm looking at the prototypes I have. None of them actually have that cable. Fantastic. I've got one of the 2 pins, but not a 4-pin. It basically, though, fits within, like, entirely within the bounds of this. So if I get dimensions off of that, I'm thinking of just cutting a slot in this orientation, a rectangle, that size, slightly larger because I'm picky that way, plopping it, like, right here in the cool S-bend we just made, and that gives us a nice, neat pass-through. Also, if we need it, I don't think we will. I think the motor wires are going to... The motor wires come out of here, and I think they're just going to go right back straight through this gap, and run all the way to the back, because the motors need to plug in way back here. So I think they're going to run straight through that way, and we'll call that good there. So let's think about this. I think I like that plan. Just punch a hole straight through everything we just did. I'm kind of cool with that. And I mean, I'm also thinking, just for aesthetics, to sort of try to line it up with this connector. Now again, nothing's ever going to be perfect. There's going to be a little slop in the screw hole, stuff like that. Nothing will ever be perfect. But I think that's kind of a cool idea. Go right in line. Is that too close to our other board? Well, not really, because really there's only wires coming out of here. Once the connector for the sensor underneath is through, it's just wires again. So wires and wires, I think we're okay to put it in line, even though it's getting close. Well, yeah, we probably want to come out. Now that I think about it, we want to come out because of the solder blobs. The solder blobs, I don't want to chance encroaching on that. So this area somewhere, same idea though. I'm going to get the dimensions of this. Right? Or actually, I mean, I may even take the dimensions of... That would give us the slop we need, the dimensions of the screen print. So from there to there. What are the dimensions of the screen print? From one edge to one edge. That is Y. That is the Y dimension. 403. So call it 400 thousandths. That won't hurt anybody. 400 thousandths there. And actually, that's not the same connector, is it? That's a 4-pin JST on this guy. Ruh-roh, did I grab... I may have bought the wrong cables. I may end up getting a chance to redo my soldering, because these, I'm pretty sure, were accurate based on what I soldered today. These are a lot smaller now that I'm looking at it. Huh. I'll have to check when I get back to the lab to make sure I've got all the right cables. But either way, I mean, if I got to go smaller, because this is going to be the driver, right? These are purchase. I'm not changing that connector. I can change these connectors. Well, either way, I got to buy a new board. I mean, splicing. Splicing's a thing. If I end up doing a video about assembly of this thing and you see me splicing wires together, we can all look back on this moment and laugh. So either way, I'm going to plan for a hole that size. So 400 thousandths by, grab the screen print again, because it has built-in slop versus the plastic. 400 thousandths by, that's the X distance, 190. 400 by 190. On this plane, I'm going to sketch. I'm going to attempt. We need this. We need it in here, though, on the part, not the assembly. I'm going to attempt to do it on this plane. I have not attempted to sketch in the air, because effectively there's no material under here. You know, I'll be sketching in the air and then asking it to cut it. I have not tried that yet in Onshape, so we'll see. Fairly simple thing in SolidWorks. There, boom. Just that simple, 400 by 190, right? 400 thousandths, 190 thousandths. There's our hole. I want to center it within here, and then we can play with position. So I'm going to grab the center here. Our standard like centering procedure here. You are not centered. Why did you not center? Undo. All right, I'm going to move this way out of whack. That's a trick sometimes to just make sure you're grabbing the center. Move it way out of whack and let the horizontal constraint, oops, that's vertical. It helps to be oriented correctly. Vertical constraint, center it. Right, let it pop it back in. Make that construction so that it doesn't interfere with our cut. And then position-wise, like, why don't we leave that 1/4 inch open? Or do something, split the difference. So a 1/4 inch of this pocket, this should be a half. If I measure from here to here, we cut a 1/2 inch. A 1/4 for the solder blob under that board, and a 1/4 out to, to give the wire somewhere to go. So this whole flat on the bottom's a 1/2. If I do 375 from here, I should be clear of everybody. I think. 0.375. And you don't even, I don't even have to do that. I don't have to pick a dimension. I could just do it and call it what it is, realistically. But that hole only, again, needs to be that big to get the connector through. Wires, the 4 wires don't take up much space at all. But we'll do that. That's okay. And then let's extrude and remove. And I don't want blind. I want through all. Through all's fine. It's just going to cut through anything. There. Our fancy little S-bend doesn't do much for us now, but hey, it's there. It's a cool feature. It looks like it belongs there. We've got a pass through now to get those wires. It'll also help control the wire once it's through there. It's not like going to flail out in space, It helps, and I can even do things like fillet this pocket and stuff and make things extra pretty later. All right, so that gives us a place to get that wire up and out. I want to go after these probably next. This one's going to be tricky. I want to cut a pocket similar to what I just did. I don't think it needs to be anywhere near as big, even though we've got the real estate, so I could make it as big. Basically to stuff, like these are pre-canned cables that I bought with the JST connectors already on them, from here to here, and they are relatively short. I don't know how short though, and I want a place to sort of stuff them. For lack of a better term, that's what I want to do. I want to have a place to put them. Actually, you know what I like better than cutting through is our whole sort of design scheme so far has been adding material to this, with the knowledge, of course, that every bit we add, every bit of material we add, increases weight, and weight's sort of a premium. I get it, but instead of cutting, like I'm thinking, so at this angle, I'm splitting the difference. At what would be like a 20, because this is 45, this is flat, 0. So at like a 22.5 degree angle, I was going to cut a rectangle here to stuff through. I think what I want to do is at the same angle come out and then cut behind, and rather than have a place to stuff through, have a place to, sort of a hook, I think, a hook-ish feature where I can just sort of tuck them up. Tuck them up, give them a place to go that's sort of out of the way. Again, we don't need much clearance because the wires aren't that long. I bought a couple of different lengths because I didn't know what I'd need. So there's some very short ones, maybe 2 inches, and so there's not a lot of space. I like that. So something like a rectangle here to here with sort of a cutout hook near the top that we can just sort of tuck the wires behind. I like it. Let's do it. First thing, we need to be in the chassis. And then I need to play, I don't know how well I can define a plane. Like, I need to get a plane right here. Actually, I need to get a plane right here. And then what I probably need to do is offset another plane above it at the same angle so that I can extrude to a surface and have it meet on both sides of the angle here. That's the plan of attack. I need to get a plane at this vertex at 22.5 degrees, offset another one, sketch on this one, and then back. Clear as mud, right? Clear as mud. That's the plan, though. Offset entities. It is going to end up being offset, I think. Is it going to be offset? Is it line angle? I don't think I want that. Well, let's play. Let's see what I got. I want it to go through here, right? I want it to go through there. And can I grab that as a reference? Plane point. All right, let's try this again. What are my options? Let's think about this. I'm not familiar with it. So probably not tangent, probably not current. Don't want a mid-plane. 3 points. Point normal, line angle. I don't know. Line angle. Not sure what that's going to do for me. Offset clearly didn't do it. Line angle 0 degrees. Like from where? From here? 22.5? Okay, I get you. I'm with you. Let's try this line. All right. 22.5 is very clearly, it's got to go the other way. Negative 22.5. Actually, from there. All right, negative 22 doesn't work. 90 and 22.5 is negative 112.5. Right? Math in my head is always dangerous this time of night. There, that looks right. Yeah, we'll go with that. Good. Boom. That's what I want to do. And I know I'm going to need one over here, so I might as well grab that and grab a plane. Where's my icon? Grab a plane. I don't want a mid-plane. I want line angle. And probably not going to be 112.5, but that's where I'm going to start. Actually, that is right. Cool, that is right. So those planes are construction now. Now I should be able to, should being the operative word, grab that plane and create another plane offset from it. And we'll have to play by ear how far, how it looks. I'm thinking probably 1/4 inch because I think that'll land us somewhere out here, but we will see. We will see. Again, plane, there you are. Offset from a plane. All right, that's 1 inch. That's 1/4. If I go, I'm going to do that because if I come here and here, I'm going to start there. We'll start there and we'll see what it looks like because the way I plan to do this, moving that plane won't really affect a sketch. So I want to sketch on that plane. How do I get normal to it? Show sketch diagnostics. How do I get a normal to my sketch? View normal to. Cool. All right, so now I'm looking at it. Both of these are at an angle, which looks good. And I want to do a rectangle. Do I want to do a rectangle? I want to get fancy. We'll do a rectangle, for now, and then we'll set one of them to construction. But we got to be careful because we got to clear the PCB on each side. So here and here, can I make you midpoint? No. I can't select the midpoint either. So I'm going to move this way out of whack. Oh, I can't. It's not dimensioned yet. Yeah, I can. I move it way out of whack, so the midpoint's over here somewhere. I'm going to throw a point in at the midpoint, and I'm going to put that point coincident with this line. Look at me cheating. Cool, we're centered. We can't go like all the way to the holes. We gotta be reasonable because we do have to clear the PCBs. So we're gonna have to do. Actually, what I'll do is I'll do this, get it where I think it needs to be, jump back to the assembly, and make sure we're clear of the PCBs. That's the plan. Make sure we're clear, and plus some, not just flush, plus some, because I'm gonna want to fill at the base of that. Yeah, that's the plan. That sounds like a good plan. I like that plan. Do you like that plan? I like that plan. Dimensions now. So let's start. I mean, this is a guess. it's a straight up guess at this point. We'll go 0.3. Why not? Height. I'm not sure because I don't think I care about the height. I think I care about where. I think I care about where it is more than the height. Let's give it 0.1875. That should be enough to get wires through, right? We're talking little wires, and actually, an eighth of an inch should be plenty. The bottom, now I want to get fancy. I'm going to construction line the bottom, and I'm going to arc. I want to get fancy, right? We're in the pretty up phase, and I will turn off construction for that because it's not construction. That's actually my shape. That's my shape. And I'm going to drop a point right at the top of that arc so that I can dimension from there, because I don't really care where the center of it is. I care where this part of it is. And that, let's do 0.1. Yeah, that's fine. And now I'm going to accept that. So I'm going to now extrude from there down to, effectively down to the surface if I can. Sketch, extrude to part. Direction. Nope. Up to surface or part. Select the part. Flip. Boom. There we go. See, that's what we want right there. Now we're connected. Okay. New. Not new. Is that add? That's add. There we go. Add. Not new. Because I want it to be all, otherwise it would have added another part down here, I think, in our little tree. That I did not want. Cool. It's probably a little tall, but I do have to fit a pocket in here. So for now I'm going to call that good. For now, but I want to see the assembly. Are we clear of the boards? We are clear of the boards, and we should have room for a pretty generous fillet. All the way around. I'm happy with that. I still think we're a little tall. Realistically, I think we're a lot tall. How far out? That was a 1/4 inch. Yeah, okay. I think we can probably drop it down to 1.875 at least, but we'll see. Let me see once we get a pocket in here. Once we get a pocket. Now, I think what I'm going to do is we're going to sketch, I think, that zoom is killing me. And I can't quit doing it because I can't, when I'm zoomed in, I can't always grab white space. I think I'm going to sketch our pocket such that it's coincident up here and coincident with this line. So coincident with this bottom surface and this line. So we end up cutting out this point and flattening it out. I'll show you what I've got in mind. It's tough to describe that in words, but what I'm going to do is I'm going to sketch on here. Right, that's the start. I'm going to sketch there. I am then going to sketch a rectangle. Okay, I want this edge of the rectangle coincident with the boss we just made. Coincident. I want this line on this surface coincident. And now when we extrude that, when we cut it, we're going to knock that corner right off, which is pretty much what I want to do. Dimension. We only really need like 70 thousandths, right? 0.1. Let's call it, if we're being generous, that's really all we need. How deep now? How deep's the question? Like how far down here? Let's go 0.375, and I'm going to shorten this. Actually, you know what we could do, since we have the extra height? I can shorten this and still have extra height. I think what I'm going to do is go 0.1, but then hook. You know, create like a hook feature to hold, really hold those wires. Make sure they're not going anywhere. I think that's the plan. So, rectangle idea is out. I've officially scrapped the rectangle idea, ladies and gentlemen. I do still need 2 lines. So, line 1, line 2. All right, and I'm at a funny angle. I recognize this. I'm at a funny angle, but these need to be perpendicular to each other. We'll just make sure that's perpendicular, coincident with the top still. So that idea stands. This now is going to come down into the boss that we created, and I'm going to kind of hook. And I can do that a couple of ways, probably with an arc. That might look the coolest. I'm not sure it's practical. I'm not sure it's practical. Let's try it. So here and here. I'm not sure it's practical because I want to be tangent there. That implied tangency. That's good. Here and here, if I make that vertical, that gives me the hook, or at least a little bit of one. And then this has got to get kind of ridiculously small. That's the kind of shape I think I'm looking for. And then it's a matter of like locating it, which we can do now. Like that's literally the next step. So if I locate here and do like 0.0, do even smaller, 75 thousandths, right? And if I make this, can I make that bigger? No, that's going to be kind of locked in now. But that should be plenty big. So dimension from that point now, because I need a certain amount of material for a lip. 40 thousandths is a millimeter. Let's go 50. Let's go 50. And then we got a nice little hook. And then I can shorten that up by quite a bit. This boss, I can bring that in by a lot. I can also, it doesn't need to be so big at the bottom. Bring it way up. Bring it way up. Because this feature is really literally going to exist just for the purpose we have outlined here, just to hook wires in. That's the whole reason for its existence. So sketch, extrude, remove. Right? And if I hit OK, right, we have knocked off that. It's a flat, it's a place to hook our wires behind now. Whether it'll work or not, I don't know. Like, I don't know whether it's going to work, but it looks cool. I mean, frankly, I don't know if it looks cool. Like, it would probably look cooler if it was a lot narrower. So maybe we do that now. Maybe we, this sketch, edit this guy. If we go narrower, 0.25. I mean, that's not crazy narrower. Not crazy narrower. And this I don't care about anymore, that dimension. I care more now about the height. I actually care about this height, right? I don't know what I need because I didn't measure that little circle pocket thing I made. So I don't know what I need, but I know it can be a lot shorter than what we've got, 0.375. Probably even a quarter. I'm going to try that. Let's try a quarter, see what it looks like. Perfect. That's actually perfect. That's cool. That's exactly what I want to happen right there. That's exactly what I wanted to happen right there. Little extra material down there. It also doesn't need to be so tall. So we can shorten basically the distance of that plane up, which is this plane. Edit and it's going to be the offset distance. 0.125. Too short. That, I think, is way too short. This is 0.1875. Let's start there. That looks more reasonable. It's still kind of a big honking thing hanging out there, though, isn't it? Sort of a big honking thing hanging out there. So what can I do? I know what I can do. I'm going to get rid of this circle, and I'm basically going to get rid of that circle, make it a rectangle that tall, and cut a diagonal through it along with a flat, that matches this flat, so we're flat on both. I like that. We're firmly in the... Oh, that also, this cut cannot be a depth. It has to just be through the next edit. Not blind. Up to next is good. Then it'll only cut through the boss. Except it didn't like that. Edit. All right, let's not do up to next. Let's do up to surface. Fine, up to face. This face. You don't like it? We'll make you like it. Okay. Let's do that. Edit this sketch. Edit. Delete. Oh, really? All I got to do is delete that. I can delete that point because it doesn't do anything anymore. This needs to be unconstructioned, and this probably needs to be a little taller. 0.375. To do what I want to do, all those things have to happen. So now I'm going to come in, and I could, I guess, S-bend it. Nice S-bend like we did before. I like that too. So let's do that. I like that. Let's do that. Let's sketch and start out with curves. An arc here, here, bending this way, here, here, bending that way. That is already coincident. This needs to be tangent. Tangent. Can't because I had too many things selected. Here to here. Tangent. Thank you. I don't have anything to make it tangent to. Can I tangent to this? No, you didn't like that. Tangent. You really didn't like that. It really didn't like that. Let's then, since you didn't like that, we'll go like this. I'm going to construction that line. I'm going to force that line to be linear. Coincident with that. Now here and here. Tangent. Since you didn't like it, we will force you to like it. Tangent between the two, just in case it didn't do it already. Also equal between the two. Again, probably not necessary. May not actually be what we want in this case. But either way, and I'm not want to move, like I really, can I, so here's the thing. Can I set this in this concentric? I mean, that's pretty literally what I want to do. Probably want to make this taller again so that I'm cutting through. I'm going to end up with a weird little flat here. But that's okay. That's okay. I can make that work. That's okay. And also, I think I'm going to do the same thing on the top and arc that, curve that guy. That'll make things kind of pretty, I think. So we need to close this sketch in though, and to do that, I want to first view normal sketch plane just for grins. I need to close this in here, here, and here. You guys are coincident. You can be coincident with that for all I care. I mean, it doesn't really matter, coincident with that. Except the sketch, because that is the cut, this sort of curvy shape. Grab that, extrude, remove, and again up to a face, and we're going to go up to this face. See the weird little flat that I foreshadowed? So we need to go back and make this taller again. this sketch, not that sketch, this sketch needs to get taller. Edit. And at that point, now it doesn't matter how tall, because we're going to cut it all off anyway. But it just gets rid of those two little weird flats. Now I'm going to look ahead. I'm going to delete this as soon as I do it. But if I come back to fillet this, I should get a nice, pretty. It can't be that big. Can't be that big. Should get a nice, pretty fillet. It's going to look. It's going to look okay. It'll look a little funny there, like lumping out like that, I guess. But that's okay. Like I'm not hating it. It'll look kind of cool. Round on top. Yeah. So I'm going to get rid of it. I'm not going to accept it yet. I'm going to do another cut, basically from here to here, make this sort of a full round. So sketch on this face, make it a full round from that point to over here somewhere. I want to be, actually I don't need to do concentric, I don't think, with anybody. I can just do tangencies. Tangent there. Actually I do. I want to go concentric. I don't want tangent on this side, because tangent on this side is going to be somewhere out in the air, and I want to do rather concentric to here. Concentric. Oh, maybe I don't. So maybe I do want to do tangent. See? This is why undo is your friend. Tangent. That's better. That's better. I mean, funny shaped here, but really at the scale, I mean, let's face it, at the end of the day, at the scale we're talking about, nobody's going to notice that it looks funny. It's not quite the same circle. Nobody's going to notice. So we go there, just to close it in, except, boom, and extrude, remove. Not blind, but up to a face, up to, in particular, that face. Kaboom. We got ourselves a little wire management guy. And then let's pop back into the assembly just to double check where things landed. Actually, looking at it, I think I kind of can move it up, but I want to be a little generous because I don't know exactly how long the wires are or how big. So I'm going to leave it a little generous. I think this gap is probably still too big. The circle might be too big a diameter still. The opening here might be too big. All of it might be able to be shrunk. But for now, that's sort of the gist of what we want to do. Now, I didn't write down any of those dimensions, and I need to mimic it over here. So I should probably do that. Where's my scratch pad? Scratch pad. Pencil. And back to chassis. All right. Back to chassis. So what did I do? What did I do? I need to mimic. I can't just mirror it. Can I? Can I mirror it? If I grab all of these extrudes, I got a plane there. I mean, I'm going to try it first. Always, like, seriously, always try to mirror or pattern first before you go back and sort of reinvent the wheel. So there, where's my mirror icon? Mirror. We want to add entities to mirror. I thought I did that. Oh, that's right. It's a feature mirror, not a part mirror. And I want to grab boom, 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 and boom. Okay, mirror plane. It's going to be you. Hey. It's red. Like, I don't know why. Oh, reapply. Oh, got to remember that reapply. Cool. Looks like it's going to be happy. Awesome. I don't have to reinvent anything. So it'd probably be a good idea, like, I'm not going to do those fillets now. I want the fillets to be absolutely last, because I'll just go through and bang out a bunch of fillets. Kind of want to do the same thing on this inside, because these two sensors pointed down. Let's go to the assembly. These two sensors have kind of the same deal going on. Right? I got to get wires out of here. Probably just going to let, these are daisy chained together on the same I2C channel. So they're daisy chained. One of them is the main, the first one in the chain. The other one doesn't have anything coming out of this. This is going to run all the way over here, probably through that same hole. So I probably want to put a feature in underneath here to give that wire somewhere to be, just like I just did. I also probably want to put something on like this wall to give that wire somewhere to go, just like I just did. Trying to think of the best way to do that. I think if we go on that plane that runs through the middle, I forget if it's right. I think it's the right plane. If we go on the right plane, sketch our little roundy shape, and then sort of mid-plane it so that it extends equally on both sides, and then cut into it the way we just did. That'll handle the wires inside here. You give us a place to stuff them, and then kind of sort of do the same thing right here. I think that might be the plan. I think that's the plan. Wires from our underneath our RFID sensor. Honestly, those are just going to be kind of ugly. Those I'm thinking are just going to be like, I have a bunch of ribbon cable with the headers, pin headers on one end and female socket headers on the other, and so I'm probably just going to peel off 8 pins, leave it as a ribbon, and run ugly out the back without any cable management whatsoever up to this header row. That's about all I got for that guy. These guys, though, we can do a little better with, so I think that's the plan. We'll start with what I said. Mid-plane a pocket thing here. Add something in this general neighborhood to do the same thing, but then the wires itself will run up through this hole, because we should have plenty of room once the connector's through and the wires are through. Once the connector's through, we should have plenty of room for another connector and wires to run up to here. Length is the only thing that becomes an issue because they're purchased and I don't know how long I bought them. But hey, that's the thing I can figure out when we put it together. Like if I got to order longer wires, right? It's not a big deal. That's part of the problem. Like I tried to shotgun ordering what I thought this thing would turn into, and don't do that. Like I wasn't too worried because again, we're talking like $3 worth of wires. But don't do that. Like, design the thing first and then order your pieces. You can do exactly what I did, working from CAD models you could download and catalog pages and stuff. But then at the end, then you can take maybe some, the right way to do it would be to take some intelligent measurements, like I didn't do, measure from like here to here to see how much cable I actually need. That would be the smart play. I didn't do it that way, so here we are. That's kind of cool. I like that though. It looks like they're meant to be there now, right? And they may look. They don't look stuck on. When it's all put together, it'll look like, hey, we designed in a place to put these wires. Even though they might. If you watch the stream, you'll know I just stuck them on. Like, let's face it, I did. But as part of an overall design, they look like they are meant to be there. So, we also have to, like, I've been overlooking it so far. We also got to get some feet in this guy, let's carry out our plan for the wires first and think about feet in a minute. Because we've only got the 2 wheels. We got to get like at least 1 more if we're going for a tricycle look. Probably 2 more for stability. Extra feet, like on the prototype of this, the 2 little 3D printed pyramids or carriage bolts. Ooh, that's all still tangled. Carriage bolts, as in the original student design. You see the carriage bolts here. The problem I'm having with carriage bolts is they're not small enough. They're fairly large threads, and I don't really want to use a regular screw, even a Phillips or a socket head. I'm worried about snagging on like carpet and stuff. The current design, the student design, runs absolutely awesome on, believe it or not, tile, like smooth floors. It ran into some struggles on carpets, and I'm wondering if it might even have been the carriage bolts, like too much drag. And I worry that the 3D printed version would be even worse because we're going to have, depending on what way we print it, if I just 3D print feet, there will be print lines, and the print lines could snag on carpet as well. So anyway, all that to say, I don't know yet. We'll do that. Let's do this first. No, let's be responsible. Wires are part of the prettying up process. Responsibility would be to get the, core features of the thing in there first. And then right now, this thing has no way to balance. 2 wheels ain't going to cut it. So there are a couple of options. In how to actually mechanically get it done. Also a couple of options as far as like orientation. So this thing, with the way we set it, I set the center line of these wheels to be hopefully under the center line of the battery, which is the heaviest component of this entire thing. So this thing should have a tendency to want to tip forward, right? So any feet we add should probably be forward. The other option is a back and a forward. I don't think I want to go with the tripod method. I think that'll be too unstable. Like, we could just put 1 foot out in front here. Could just put 1 foot out in front, call it a day. I don't think I want to do that. I think it's too unstable. And as I'm looking at this, I'm thinking for feet, I'm thinking of using this shelf that's already here somehow. I just don't know. That that's going to be. I can't. So, first thought, like honest first thought, would be to grab these and just extend them all the way to the floor, because they're already there. The problem is I added sensors down here. Sensors which have to be able to get a laser beam out. Now, I can encroach on my screw holes. I can, because at the end of the day, I can always hop into my chassis here and move those screw holes down below whatever feature I add, so that the screw holes punch back through any material I add. So that's not a worry. The worry is if I just come straight down, I'm blocking those sensors I added in. That's the real worry. That's the real worry. What kind of space do I have here? I kind of like the idea of aesthetically. I don't have a way to like draw on my screen. That's like the drawback. I'm a teacher. I'm used to being able to draw. I like the idea of like coming somehow. Mind you, I don't yet in my head even have an idea. Somehow having some kind of an arc. We talked about this before, like when I was complaining about these holes, which are now going to be useful to get my motor wires through. Right, I'm going to close them in. I think I'm going to close this in so that there's just a channel to run the wires through. So like from here to here, just put material, box this in. It would be pretty simple to do, and then it makes, again, a channel that looks like it belongs there. But we talked about like coming from the back all the way forward and doing like a big sweeping arc down into the feet. I think I like that idea still. It doesn't quite work in those channels because these are now in the way. But if I could somehow do it and pick up these feet, it's kind of what I'm thinking. Like something, we got to clear the motor, we got to have room for wires to come out, but something like an arc to here, out to here. Right? Something like straight down, give us whatever kind of platform we need to mount, and then arc up. Just making sure that we're inside. We're inside. If we're inside this, we got all the room for wires we want. So like from here to here, out, down, right? Making that happen is going to be fun. And I was thinking, I can actually encroach like in this area where this sensor is if I punch a hole through it. So I mean, I could come straight down with those don't know that that's a super swell idea anymore. But I could always punch a hole for the laser to get through, because a hole the size of that sensor is really all the hole it needs. Again, bigger for clearance just to make sure, because alignment is alignment, right? CAD's perfect. The printed parts will not be. Which version? Which one do I like? This is a, this is a picky decision now. I like the idea of, again, those acting like they belonged there the whole time. I kind of like that idea. Pretend that they actually belong there. What I'm debating is, do I like the idea of just having big pillars, just straight down pillars of plastic going all the way to the floor? I don't think I do. I think what I want to do is I want to come in here, stay inside of the wire, but go from like here straight out to the front and sort of sweep down for legs and let these sort of exist the way they are. I think that's the aesthetically thinking ahead, trying to visualize. I think that's the play. So, I guess, question, I want to be inside of this. And these models, I don't trust the motor models one bit. Not one bit. Because I measured a few in one of these episodes with a caliper. I measured a few of these dimensions, and I don't trust them one bit. But for an idea of where I need to land, like these are skinny terminals, like this is a plastic housing over the motor. The terminals are way skinnier than it. So there's some leeway, but I'm going to use that as the base. Like from there to there, I need to know the dimension. 474 is good enough. So I'll go a ½ an inch in. And what I want to do now, because I think I want to base it off of the right plane, is I want to measure from the right plane to there, 2.675. So if I go a ½ an inch in, that's 2.175 off of the right plane is where I'm going to sketch my little foot. And I'm going to see what it looks like there. We're just going to do it. If I have to undo it, that's fine. Delete is as good a friend at this stage as undo. I can always, I'd rather, the old adage goes, I would much rather get it right in CAD than have a bunch of parts, printed that don't work, right? Get it right now where it's cheap. Time-wise, material-wise, everything else, it's cheap to fix in CAD. All right, so we need to sketch on that plane. I want the right plane. Probably even with that is where the front is going to be, and then, like I said, I'm going to come back and sweep up. I need to sort of bounce back and forth between assembly though, because I also need to know like where this is. So let's measure from there to the motor. 163. I don't know if that's parallel distance though. I want truly along Y. Okay, it is 163. 163. I'm going to call it 200 thousandths just for grins, right? Gives us some space forward just to make sure, even though we're inside of it. Do I need to do that? I don't actually need to do that. I don't need to. I can come right up to it if I really want. So let's call it 100 for now. Is where we'll start. Now the tricky measurement is going to be, I need to know from the wheel up to here to know where to stop. Right, to know where to stop. I also want to hop over to McMaster and see again. All right, it's going to take me, because I've been on the threaded insert so long. So let's back out. Let's go to screws. I definitely want to, if we're going to do something. Oh, I forgot those existed. That right there is an option. A spring plunger has some of them, not all of them, Some of them have a little ball bearing. It's a ball nose. And if we put that in, that ball bearing becomes a wheel. I kind of like that idea. Can I get them in metric? And I probably want them pretty big. I've already got M5 threaded inserts for the main board. Extended, compressed. Is that all metric? Oh, I don't need stainless. So that's the longest. I'm assuming. This is a big assumption. Well, let's check the... I mean, we don't have to assume what... I was going to say, let's assume spring plunger, spring plunger. So a spring plunger driver is really just a screwdriver with the center cut out, so you clear that ball. Nylon nose, steel nose. Definitely steel nose. Let's do the longer guy. Just try it. Let's check out the details. We've got on this almost 1 millimeter of steel ball sticking out. A 3 millimeter, that's not a diameter, but 3 millimeters wide, 9 millimeters sticking down. And then we're actually running on a steel ball bearing. Huh. I kind of like that idea. Cool part is, if we put an M5 threaded insert in there, we're going to have to make the hole extra deep. Those inserts aren't 12 millimeters deep. Oh, that's the other problem. Ooh, that might be a problem, because these, I mean, these are spring plungers, right? Spring plungers. If we set weight on that, it's going to want to push the ball up in. How much weight does it take? Nose force extended, 3.5 pounds. This thing isn't, I haven't weighed it. This thing is not 3 pounds. Like this version, I haven't gotten an actual weight off of it. This version is not 3 pounds. But at the same time, while we're here, so this is definitely an idea. I'm going to go ahead and download. Uh-oh. Specify locking type. Oh, without a thread locker, please. I don't want to Loctite the thing in, because what I'm thinking, if it's threaded, like we've got a threaded insert, we've got a deep enough hole to fit this, we can put almost any M5 thing in there that we want. Let's grab a 3D step file, download. I'm going to grab that. And let's go back shopping. That is not the worst idea I have ever had, trust me. There's also long nose. The thing I would worry about with a long nose, we're not really running on a ball. It's more of a detent, right? It sticks out way further. I'd be worried more about side loading, because these aren't really meant to be side loaded. We'd be running on a nice smooth steel rod effectively, but I'm not sure. I'm not sold on that particular idea. Is there anything else in here that might? No, I don't think so. Long nose is an option. It gives us more clearance. Like, that could be an option. Like, say this sort of works ish, but it, like, maybe the slots get hung up on carpet. This might be an option to push, you know, to push the slots back further, up further. So that might be an option. Like maybe the ball. And this is the thing, like the design I've done so far, the steps I've shown you so far, we've done our due diligence, we've checked dimensions, right? I am absolutely 100% confident that when I get these parts in hand on a workbench, that they will go together. This thing will assemble, okay? I have honestly, and I don't intend this to be a flex, but I guess it kind of is. I've never done a mechanical design that did not go together, okay? That is a different statement than when I get this on a bench and get it put together, it may not work. That's a different statement. I've had designs where I've tried something and it didn't work. Like it didn't do the job it was supposed to do because I tried something. That is a distinct possibility with the ball plunger idea. Like it will fit. It will assemble. Will it work? Oh, Till I get it running around on a piece of carpet, that would be my main hang up, right? That's not a lot of ball. There's under a millimeter of ball. It sinks into the carpet. The screw slots on the plunger get caught in the carpet, and we end up with more drag. I can't do much about that right now until we test, right? But it will assemble. It'll go together. And that's a huge thing, right? Just that it goes together is a huge thing. We want to do our due diligence to make sure that we can have a prototype to test. If it doesn't even assemble, I won't know what works. Like, I guess in 7 episodes, we're coming up, so 6, 12, this is like 13 and a half hours on this design. If there is no other takeaway I can leave anybody with, it's that sort of pearl of wisdom. You want to make it fit. You don't know if it's going to work, and that happens a lot. So that's an option, and that's an option I'm going to try first, right? And maybe we come up with plan B at the same time. So carriage bolts, when I was in here last, I did not think I saw, well, there is an M5 carriage bolt. M5, of course, that's, yeah, okay. Fully threaded, 10 millimeters long. Product detail. Now, the thing they don't necessarily... Now, I don't know. I'm going to say this, and I honestly don't know it for sure when it comes to metric. Is that I think part of the problem with drag on... Grab the wrong robot. On the old version, those carriage bolts, those have actual cast-in letters. Designation for what the bolt is. What is it? I don't know what the symbols for carriage bolts actually mean. I'm assuming a grade. I don't know on the metric version if that's the same. I don't know if there's going to be letters on this surface. Like, this shows it's smooth because somebody modeled it in SolidWorks, and it's, you know, it's smooth in SolidWorks, right? But that doesn't say that the manufacturer doesn't cast in grade markings or something that stick out and will give us drag anyway. But we'll call this plan B. I mean, there's an M5 carriage bolt. If we make the hole, we're going to make the hole nice and deep for the threaded insert. And we can go longer, even. I don't remember how long the... how long is the... Let's go back to that spring plunger. I do like that idea, and I might even... I mean, maybe I buy all three, and this is the testing phase. Maybe I buy these, and the carriage bolts. But to do that, I need to design sort of for the worst case. So this guy, M5, and the guy I grabbed. Now, I could always go bigger. That would give us a bigger ball. Nothing says I'm stuck to M5, but I've already got the M5 inserts in the design. So that's where I'm starting. And I definitely want a steel nose, not nylon, just for wear purposes. Steel, that's the long one. Does it tell me... So 12 millimeters long. That is, I know that's longer than my insert. So I got 12 millimeters on that option. If I go back out to carriage bolts, where are you? Go back out to carriage bolts. Carriage bolts. One more back. Okay. Carriage bolts. M5. There's a 12 millimeter option, and that should be, I don't know if that's thread length or thread length. So that's thread plus the square. The square is 4 millimeters. So what I'm thinking is I can actually live. I'm thinking to put the threaded insert in flush with the plastic I'm about to model, with a nice deep hole behind it for extra thread from whatever screw. And I'm thinking of just eating that extra 4 millimeters, because this square portion will not thread into the insert. That's what it's there for. It won't thread in. And just eat the 4 millimeters, and then the thing, I mean, the robot will sit kind of cocked by 4 millimeters. I don't think that's going to make much of a difference. So I think we're going to do that. Well, this is plan C. Plan A, spring plunger. Plan B, long spring plunger. Plan C, carriage bolt, original design. The cool part is, with what I'm about to do, by putting a 5mm threaded insert in here with a nice deep hole, is that all it takes is pulling the spring plunger out and putting a carriage bolt in if it doesn't work. So, planning ahead, right? Planning ahead. Now the question is, we got to get plastic in, right? Got to get the plastic in here. So, also, now that I'm looking at this, my plan to put a leg in here is going to make it an absolute nightmare to get at those screws. Crap. And actually, if I just extend these down, that kind of makes it a nightmare too, because I don't think I can just. This cylinder is as small as it needed to be to make room for the M5 threaded insert. I don't think it's thick enough. I really don't, to just drop it all the way to the floor. I was going to make it, if I was going to drop these, I'd make it bigger, which is going to then encroach on the screw holes and make it impossible to get to those. Because if I come straight out the way I want, I basically can't come any further than that. Crap. That's not good. Why do we have to be that way? Why do we have to be that way? So, what if I got rid of what I just did, these hooks? That sucks. Delete them again a second time. I deleted them once, right? Delete them. Get rid of them. Just get rid of them. Do the same sort of idea. Material out here, but new material out here are our legs. That's not really stable. That's not really stable. So what do I do? 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 Lots of options. Lots of options. None of them really swell. None of them really swell, because I kind of want to land, like, spacing wise, these are kind of ideal. I don't think I want to go all the way out to the edge for looks. Like, I don't want to go all the way to the edge of the chassis just for aesthetics. Spacing wise, those are already, like, centered about the center plane. They're nice and wide for stability. I don't want to just run them straight down to the floor. But if I'm not very, very careful about whatever I decide to do, we're going to run into issues with assembly. I can't get a screwdriver in there to get the screws in, or I'm going to block those lasers. One of those things is going to happen. As I was talking through that, through my mind was running a radical idea to put some sort of a skeletonized leg in there, rather than the chunky single piece pyramid design. Something like this, except hollowed out, like carved triangles through it, so it's, legs of a pyramid rather than a pyramid. What does that look like, and how, frankly, how the hell do I do that in Onshape? I am honestly not even sure how I would go about that in SolidWorks. So a pyramid that lands me, my foot kind of in this area, right? Kind of. I'd want to be equidistant, so like think triangle this way, a three-sided pyramid. Triangle like in this vicinity. We might have to rethink our hole here. Oops. Right? At this point, anything goes. Anything goes at this point. But sort of a triangle this way. But that also tapers toward the floor, the way the pyramids here do. It gets narrower as it gets towards our threaded insert. If it's hollow, it's already open on the inside, so I don't really need a deep hole for the threaded insert. I just need enough material to actually hold it. Then if I put the longer screw in, it'll stick up into it. Who cares? You'll see it because everything's wide open, but who cares? What I am noodling on right now is how to make that pyramid shape. That's really my entire thought right now, is how do I make that shape? Because I don't know. I truly have no idea. How would I even do that in SolidWorks? A loft, maybe? A loft with some controlling curves to force it to actually be a pyramid. Can I do a loft in Onshape? A loft, I think, would get it done. Chassis. A loft would get it done. Is a loft an option that I have? I can extrude. Yeah, here, you can extrude. Intersect or thin parts. Can I loft? I don't even see a sweep. Like revolve. So first of all, I don't remember what sketch I was in, so let's get out of it. I was creating a sketch. I don't remember what I was going to sketch the wire channel. What do we got? Let's see. Draft is not what I want. Loft. Oh, I was in the sketch, so loft went away. There's my loft sweep. Thicken I shouldn't need, and close I shouldn't need. Loft. By placing a smooth face between ordered profiles. I mean, I don't know what that description means, but I'm going to assume that it is the standard loft like we are all used to. Now, problem is I've got screw bosses in the way. Well, I can always recreate the screw bosses. Again, I can always move them down. Like if I'm about to seriously encroach on them. let's just be real about the situation I suddenly find myself in. I am about to seriously encroach on the screw bosses. And I think I'm going to get out of it by doing what I plan with a loft and then moving those features way down the tree so that the loft no longer encroaches on them. I think that's the way to get out of it. So let's encroach. I'm going to sketch on this plane. First, I need a plane for the second sketch, like the bottom of the loft. The bottom of the loft. So I need to know, I started this thought before I need to know distance from like the bottom of that wheel basically to here, and then I need to subtract, I mean, at least a few millimeters at least to get room for the ball, or I could probably split the difference. That way, with the ball, it'll be tilted a little down. Maybe with the carriage bolt a little up, I can split the difference, or I just not thread the ball insert in all the way, and just plan worst case. Does it tell me how tall that head is? It does. So 7.4 millimeters is going to be my plan. I'm going to stop the loft I'm about to create. I'm going to stop at 7.4 millimeters from where the floor plane will be. I just need now to figure out how to get a floor plane in. I don't think I can add a plane to I've tried. I don't think I can add a plane to an assembly. Kind of sucks because sometimes you want to do that, like to mate things too, but I don't think I can. At least I don't believe I can. And this thing is not sitting on, well, there are no planes in an assembly here in Onshape. So what if I just grab this diameter and this, and will it give me a distance? Like, let's check the distances. Not center. Min distance, no. Center distance, I guess. Center distance plus a radius? So center distance is 450. 0.45. Oh, I'm going to just chop it off there. Diameter, 2.5. So 1.25 radius, 1.25, means the floor should be 1.7 if I'm mathing right at 10 o'clock at night. 1.7 to the floor from that bottom. Then we got to subtract 7.5 millimeters. So let's make this millimeters. Well, no, 7.5. Let's do it the other way. 7.5 millimeters to standard. 7.5 millimeters, 25.4. 295. 0.295. So 1.7 minus 0.295. 1.7 minus 0.295. I'm going to call it 1.4. We're 5 thousandths over. I'm going to call it 1.4 even. I should know that. It's getting late. Math skills go down with time. I am very much a morning engineer. My peak is in the morning. You're getting the worst, which means it only gets better from here, man. Which is good because this is pretty terrible. So 1.4. I'm going to make a plane on the chassis 1.4 off of here. That's going to represent the floor. Plane. Not the floor. That's not the floor. I'm actually going to do 2 planes. I'm going to offset at 1.7. Okay. And I'm going to name it and just leave it be. I'm never going to change it. Oops. Rename. Floor. Never change it. Right? Now I'm going to create another one at the 1.4 that I actually need, and that's going to be where I'm going to loft to. So plane, where's the icon? Right there. 1.4. All right. So there's our delta for like screw stick out basically. And then when I drop that in until I get the other purchased pieces in, well, I can't see the planes. I might be able to see them. Can I show planes? No, because I don't have an expansion here. So this is the plane that I'm going to sketch, like the second loft sketch on. The first loft sketch is going to go right here, and again, I'll move the screw boss and the screw hole down in the tree later to sort of get myself out of the mess I've created. So let's sketch. Ooh, this is going to be iffy. This is going to be iffy. I know what I want in the end. It's a matter of how do we get there. A hollow pyramid is not a thing that, I mean, this may come as a shock. That's not a thing that pops up a lot. Like, it's not a thing that's required a lot. Now, I had a measurement. Did I take it to where the front of that motor was? Like the front of that motor, I want to be clear. Well, it was from here to here. I wanted to be inside it. Well, wait, clear was before I decided to go nuts with pyramids. So really, clear inside doesn't matter much anymore, but I want to know where I could start it. 1.64, I'm going to call it 1.5 away from that front edge. So let's go to the chassis. I'm going to start on this side, well, on this side, because there's no hole. That's really the only reason I'd start over here. This hole doesn't exist. It won't matter. I mean, we'll plug the hole, but here, triangle will go right out to the edge. Why not? And then close it. Equidistant. You can't be. Geometry, you can't be equal. Then the sides here are going to be 1.5, and we're defined. Yeah, we are going to encroach. We'll fix it later. Piece of cake. We'll fix it later. Do I need to be 1.5? Yeah, we're going to start there. We'll see what it looks like when I get done. We're going to start there. I was thinking because we're going to taper in 2 directions, and I'll show you what that looks like right now. Sketch on that plane that we created. I'm not on the floor. I'm on that plane, and I'm going to create first. This is strictly construction. So let's do construction now. Construction, where are you? Okay. All right, you are construction, right? You are construction. Now I can set it. I'm going to set it equal to this because I need to get a 5mm insert in there, and this was already set up for a 5mm insert with the right wall thickness. So make those equal, right? Now I'm gonna just enclose this with a similar triangle. Similar triangle. You and you are equal. You and you are equal. Now the question is, where? I think I want it centered in this triangle, and I think I probably need another construction line in order to do that properly, which I can do. I can actually do that right now. No, I can't. Crap. That needs to be in the other... This circle needs to be in the other sketch, I think. So let's exit out of this sketch and edit the one I just created. Because I want that circle, edit, I want that circle to act as like, where is the lofted triangle going to land? Now the question I'm asking myself still in the back of my head is, how in the hell am I going to hollow this out? I truly don't know yet. Can't tell you. I haven't thought about it. I'm noodling it as I'm going through the motions of creating this. But to center this guy, I'm going to grab the center line here and that point. Construction that, and then here and there and center. That's not back as far as I wanted it to be. That's too high. There is a geometric trick. Because what I'd like the gap between all of these flats to be equal. So this distance equal to this distance, and you can visually see it's not. So I want to undo that. There's a geometric trick as to where that point is, and I will be honest, I do not remember what it is. For now, I'm going to coincident those. Again, at 10 o'clock at night, I don't remember what it is. It's not half of this height. There is a formula for where that is to get like truly centered with these gaps equal. That has been a minute since I had to worry about such things. Can I do this? I mean, maybe I can cheat it. Can I do this? Touch here, touch here. I can cheat it maybe. And then this would be vertical. Touch the circle, straight up. Everybody's construction. Like everybody I'm creating now is construction. And then cheat it. I didn't get you. Construction. Thank you. You and you are equal. If you and you are equal, that should lock down. No. Damn. I need another one. Because I can still move it. I need another one. I need another one from here to circle. Here to circle. To here. And... can I delete that safely? No, because now I can move all over the place. Oh, I can define you as perpendicular, and that'll lock you down. Perpendicular? Cool. Now I'm locked, and I don't need that center line. Now, you guys need to be construction. And finally, the cheat, you and you are now equal, and that should force everybody into compliance. Now we're centered. Now, finally. I was hoping to end this on this episode, but it looks like we're going to need at least one more because your genius host forgot that he needed feet. So that now, on a new sketch, now on this plane, the loft plane, I should probably name it. The loft plane, I can draw a similar triangle tangent to all three sides to that circle. Here, 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 and here, tangent, here and here, tangent. Okay, you and you are equal, equal. You, whoop, not the whole thing. You and you are equal. Now, oh, that's right, you can't be equal. I didn't mean equal, I meant tangent. Now, I know I have enough material in there to put a hole and have the wall thickness I need for an M5 insert. That was the whole exercise behind that construction circle. Now, that is a bigger triangle than I wanted on the bottom. Way bigger. It's way more forward than I wanted. It is hopefully not going to encroach on our lasers or our screws because I'm going to hollow it out. I hope. I don't know. Like I don't know. I don't know how I'm going to hollow it out. It's not as simple as one would think. I don't think I've got an option. Like, I mean, a sweep might do it, but I'm going to try it this way. And we may have to come back to this, next week with me having failed and having, like, cool part is I can try it over here. If it doesn't work, I got another side. I can play with some other idea and sort of pick the better of the two. That's what I'm going to go for. Let's go for that. All right, let's loft this bad boy. Profiles are, I need that whole profile, not just, see, it's cut off by my cylinder. Let's grab the whole sketch. Okay, you'll let me grab that. Let's grab that sketch. That's profile 2. That's what I'm looking at. That's what I'm looking at for a foot. Now, envision that, say, this thing is hollow only, so like there. I don't exactly know how to do that right now. A lofted cut and then maybe cut through the faces. I could do that. How is that going to work? How's that going to work? What I really need. So, I mean, I like that. I kind of like the shape. I actually wish it was sort of like this edge is tilted not enough. Aesthetically, I would like that to be back more. Which I can do if I don't have to meet. Well, let's accept this. Let's accept it. We know we're screwed right now, right? Nothing works this way. But I want to see it in the assembly and see where we're at compared to the motor. Like, I got a mile. I could come back. What is the actual distance between there and there? In what? Y? The green direction is Y. I got another 150 thou. That I could make that bigger. And I kind of want to do that. Let's make it 125 bigger so that we don't go completely insane. Let's make it 125 thousandths bigger. So let's go back to the chassis. Let's edit that sketch of the cool part is of Onshape, like I haven't mentioned this, I like that it kind of leaves the sketches out. It doesn't bury them in features, because a lot of times I use sketches for multiple features and then you got to unbury them, figure out where it is. I kind of like that it's just left out, that it doesn't bury it in the feature like SolidWorks does. Let's edit that sketch. I said add 1/8 of an inch, right? So 1.625. That we could get bigger. Of course, our circle shifted a little, which is going to shift the other sketch, which is fine. And that's still not tilted as much as I'd like. I think it would look cooler tilted more. Anyway, what I was getting at about needing, about hollowing this guy out is what I really need is I need a plane. Like, I need, I don't know what, like 5 millimeters material for the insert. So I need like an intermediate plane and another triangle. That's a little tough to do That's a little tough to do because you don't really, I mean, you can calculate, I guess, but you don't really know what size that intermediate triangle needs to be to get you the triangle on the bottom that you need. So it's not an easy thing. It's a doable thing, because what I could do to hollow this out, and in fact, I mean, I should probably do it. I should probably just shut up. I should probably just shut up and do it. And actually, I'm going to shut up and do it. Because what I am going to do is I'm going to create two more triangles, one on each of those planes. We will loft what is already a hollow pyramid. I will then cut on these faces through it to the next face. On these faces, or on this face, one or the other, to the next face, and that will give us a skeletal pyramid, which is what I'm looking for. And in doing that, I can leave myself, or I later, I shouldn't say I can leave myself, later on, I can come in and fill in material for the insert. That's the new plan. Sketch, edit. First of all, I'm going to delete the loft. Delete. Edit this sketch. And I just have to determine how thick the walls need to be. We need another triangle inside the other one. Boom, boom, boom. Okay. Make sure vertical, all that good stuff. Let's go to a bottom view to make sure. Vertical is good. All right, you and you are equal. Okay? You and you are equal. You, I need dimensions. Wall thickness. I don't mind 150 thou, I think, so let's do it. Wall thickness. Now, whoops, what did I do? 150? Oh, 0. It's late. It's late. We've been doing this a minute. We've had a couple of failures. Cool part about failure at this point is it's as easy as undo and delete. So, I mean, it truly does not bug me much. Does not bother me much at all. Same thing on the other sketch. Edit that sketch. And I can go inside because I can always fill in the material. Because I need, like, the outer bounds already. So that works. Do this. Parallel's fine. Doesn't really matter. You're going to be horizontal. We're going to stick with 100. Well, first equal these guys, and we're going to stick with 150. If you heard the door, by the way, that was an office dog wandering in. Everybody needs an office dog. 100, not 150. And I'm going to fill this material in 0.15 later. We're going to see if this crazy plan works, because I got profile, I got profiles galore. All right, let's loft. Profiles. Profile 1. Profile 2. Okay. I don't like red. Seems to me it's not gonna, it's not gonna like red. Cannot use faces with inner loops. Crap. Really? Why didn't this one turn red? Like, why didn't you turn red? Let's grab that and grab this, I guess. Okay, it doesn't like that one now. It failed. It must have failed. Like, all right. All right. Well, folks, I mean, it's at like the 2-hour mark. I like to keep these at 2 hours, mostly for my sanity. I may have to noodle on. I won't. I have resisted the urge. I mean, the other option. The other option is to, let's try this. Let's try one more thing. I was going to call it, I got greedy. Let's try it. Sketch 35. Less that. No, no. I don't want the inner. I want the whole thing. I want the whole thing. Give me the whole thing. Can you give me the whole thing? Can I have the whole thing, please? That I want it minus this is what I really want. I want to subtract, but I want to leave it intact, and maybe I can't do that. Let's edit the sketch and delete the triangles we added, the inner triangles. So that we just have closed triangles, because we know that loft works. It doesn't like a nested contour in SolidWorks terminology. And I can't blame it. I mean, that is... So under the hood of any CAD system is literal geometry. It's just geometry. They're all the same because geometry doesn't change. The front end changes, how they interact, you know, the interface changes, that kind of thing. Under the hood, they are identical. Under the hood, they're absolutely identical. I'm going to show these sketches now. I'm going to recreate my triangle based on those sketches. So on this plane, I'm going to sketch. And I'm going to do a loft, but I'm going to do a remove and see if that'll hollow me out. It should. I'm sketching. I need a triangle. I'm trying to remember where I'm at. And then we're going to call it. If this hollows it out, I will skeletonize it real quick, and then we will call it a night. And I think I'm going to go down from 150 to 125 just because I like it better. But those need to be equal. From here to outer wall, 0.125, because that is going to end up being the wall of our triangle, the wall thickness that we're shooting for. 0.125. And because we're offset the same distance on both planes, it should be a parallel cut. Like, it should be nice and hollow and even. I'm going to rehide that sketch because I don't need it. The original lofted sketch. This one actually I don't need either, so we can hide that again. But on this plane now I need to make a sketch. Actually, I'm going to do it on the plane, not on the surface. I don't want it defined by the surface, I don't think. One of those things, it's hard to tell. That could cause heartburn later on if I move something. Will it be an issue? Probably not. Do we really need to worry about it? Probably not. But it could potentially be an issue. You're not vertical. You need to be vertical. You are horizontal. All right, both of you need to be equal. Equal. And then we'll go 1/8 of an inch again for walls from here to here. 0.125. And then I don't understand why it moves things so far. Like, why? There's no reason that it needed to jump that far. So 0.125 everywhere. Everywhere. 125 everywhere. Can I just grab these and loft them ahead of time? Yes, I can. We want to remove material. Yes, I can. Oh, buddy. Oh, buddy. Again, look, I just cut away my cylinder. That's okay. I can move it back to the bottom, I hope. Like, I hope. I didn't dimension anything off it, I don't think. That would be the only thing holding me back. So we're hollow. We're screwed because we can't get to those screw holes, and the laser can't see out. But now the trick. The trick I was shooting for from the very beginning on this face. This may not be the way I want to do this on this face. I may want to go on this face, but the idea is going to be to sketch. Okay, and basically sketch the shape of the face, and hope for the best. I mean, hope for the best. Can I go? I want to go parallel here. Can I do that? Because we're getting funny. We're getting into funny territory as far as geometry goes. Parallel here. Those are parallel. I can't really set anything equal. I don't think. I do need to come down a little bit because I'm angled in. If I just go cutting and I'm even here, I'm going to cut into my original chassis bed. I don't want to do that just for looks. So I'd rather come down at an angle a little bit and cut up. Ideally, I'd end flush. But that would require way more math than I'm willing to do. I mean, let's be real. Way more math than I'm willing to do. Now, so to skeletonize this, I'm not actually sure where the best place to go is, but I'm going to try this. I want to go, can I go coincident with that? Yes, I can. All right, that's the idea. And same on the other one here, if it'll let me coincident. Okay. And so I did need the I didn't need the parallel. I didn't need the parallel constraint, but that's okay. That's what's an extra constraint between friends. Give it a dimension here. Whoa. You need to be parallel. You definitely need to be parallel. All right, and then give it a dimension here. Just again to make sure we're offset. We want to be offset so that we don't dig in. And I'm going to call it 005, 50 thou, just to see. I don't remember. This needs to be the depth we need for a threaded insert. I don't remember what that is. So for now, knowing it might have to get thicker later, 0.1875. Might have to get thicker later. Might be able to get thinner later for all I know. I don't know. Accept that. Grab that, extrude, remove, and up to face, and I'm going to grab the interface. Okay. Boom. We're hollow. We're skeletonized on that wall. Rinse and repeat for 2 other walls. Sketch, outline the thing. Okay. Outline the thing. Constrain these. I shouldn't need the parallel. I can constrain it to that inner line. Coincident. And there might be a better way to do this. I'm honestly blanking on what it might be, and I did 50 thou off the top. I could probably go shorter, but based on the other one, there looked like a little show. Oop, why didn't you like that? Why are you fully constrained? I don't like... Why are you fully constrained? Alright. I guess... oh, no? Because of the bot. I was going to say because because I grabbed coincident, but that should have locked down that point, especially since there's no point there on the inside for it to have locked it down to. So why, like, you're coincident, yeah, because you're a shape. Why are we, all right, like, we're not on anything, blow it away if we don't like it. Here, 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 horizontal, okay, boom. I think it added a constraint. Like I'm seeing the origin there light up like it added a constraint on us automatically that we probably didn't want. And like that point already should not be locked down. So the other one worked well when I went way out of whack on that. So let's just go way out of whack and try to avoid it tossing like hidden constraints at us. So you. Coincident. There's a way in SolidWorks to shut that off. I don't do it a lot because every time I do it, then I end up missing it. I'll be frank, I miss it, and so I just live with. I occasionally shut it off for a minute, you know, when it's being particularly annoying and I got a particularly complex sketch going on. And this, what did I do? 1875, I think. Whoop, nope, because you're not parallel. I went out of whack. You and you. Parallel. And then dimension 1875. 0.1875. Now, this may not work. I may still be in the middle of my laser, but I think that laser is going to shine right through this hole. I think. I think we're going to get lucky. I may have found a way out of a problem that we worked ourselves into. Extrude, remove, face, and that interface. Okay, rinse and repeat. Rinse and repeat. Here, sketch. This one's going to be tricky just because of how hidden it is behind everything. There's no real good way to see it. So again, avoid automatic constraints for now. So you, and is there still an edge there for me to coincident? Yes, there is. Coincident. You and coincident. You and parallel. And let's dimension 1875. Again, the 1875 might change. I don't remember how deep we needed to be. And then I can fill this triangle in to get our material back for the screw, for the threaded insert. It's a bit of a roundabout way to do it. I'm short of ideas on how to do a better, like, skeletonized thing. 50 thou. All right, accept that sketch. Extrude. I forgot to select the sketch. That sketch up to face and that interface. Kaboom. Remove. Kaboom. Now, we're funny here, but if I look now, can I get to everybody? Can I view normal? Yep, view normal too. Oh, that screw's gonna be hard to get to. It might be doable. It might be. Let's view normal. I mean, they're all going to be kind of a pain, but at least I've got some approaches here. That one's going to be kind of a pain. It's also going to be kind of hard to make all of that inside there pretty. But that's the thought. I think this sort of funny angle on these faces, notice they angle up. Those I can kind of get rid of when I come in here and extrude. I can extrude a little further and flatten that out when I fill in this material. So I'm not too worried about that. But that's kind of the thought. I mean, do I like that? I think it fits in with like the theme. We're pretty geometric. I do want to round things out. I still want to double back and round things out. But overall, we're pretty geometric. This is getting kind of narrow for what we're going to be asking it to do. Like, how far apart is that? Can I get a dimension? 1/8 of an inch. That's kind of small for what we're asking it to do. I am not going to lie, that is kind of small for what we're asking it to do. So I might want to go with thicker walls. Like that 150 might not have been enough. But that's the look, the idea. It's not exactly the way I wanted it to turn out, but that is the idea I was going for. And if you know of a better way to get that done in like one move, preferably, let me know in the comments. I personally don't know that I know of a better way to get that done. So now, I before I sign off, again, I'm way over my 2 hours now, but I want to grab that extrude. And I want to grab that extrude and which hole is that? Which hole is that hole? I want to grab those two things if I can, if it'll let me do it, because they're so far apart. And I want to drag them all the way down to the bottom. And I'll have to do this again after I do the other side. Drag them all the way to the bottom, if it'll let me. Okay, it did. There we go. The screw boss is now intact. Right, like I said, that's an easy fix. And actually, I can take everything we just did and I can mirror and that'll be my last act for the night. Part mirror, we don't want a part mirror, we want a feature mirror. And we want to reapply. Mirror plane we can define now. That's going to be the right plane. Features, basically everything from that loft, that loft, here, 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 and not that one. Basically that. And then I need to, again, remove these down after that mirror to get my screw bosses back. So now let's take a look in the assembly. I mean, come on, like, yeah, that's going to be tough to get to that screw, but come on, that looks kind of cool. That's way high up off the wheel, but I guess we did our math. So so next week, I guess the thing would be to sort of finish this off, get, you know, the threaded insert in there. This is bugging me, how thin that, an eighth of an inch, it's basically an eighth of an inch square. If we really think about what it's doing, hanging out there, especially when this thing turns, depending on which way it's turning, you know, which one is eating it, but that 1/8 of an inch square rod, pillar, whatever you want to call it, is going to eat all of the force on that foot. It's going to be in tension. It might be okay. I don't know. I'm nervous about it. I am nervous. And we can clean up that hole too. We can just cut that material back out. We definitely don't want to do it as a through all though, because then we'll cut through our new. We can also move that hole down to the bottom. We don't want to do it as a through all though, because then it'll cut all the way through our nice loft, and you know, which won't exist anymore. But that looks, I mean, from an aesthetic standpoint, man, that looks way better than I thought it would. that's for like 45 minutes ago, having completely forgot that we needed those features at all, to a skeletonized version. I like the proportion of that front leg. Like, proportionally, just the looks of it to me look good. I don't like the lack of cross-sectional area and the force that I can envision that it's going to be taking. That's what I don't like. It's going to be a little flimsy, I think. So I may need to beef up that 1/8 of an inch wall for our extruded cut, or our lofted cut. That might be a thing that has to happen. We'll decide on that next week. So I'm going to switch back to the full screen because I want to thank everyone for tuning in. This was not the final episode as I promised. I thought it would be. I thought we were going to get into the cleanup after, you know, some of that minimal wire routing stuff. But it turns out that this thing just will not die, right? And that's the fault of the designer. He forgot a key feature, so we got to make it work. And I guess the key takeaway towards making it work is that I didn't just make it work. Like, the easy play would have been to probably extend those screw bosses down as just straight cylinders and call it a day. But I didn't like that. Aesthetically, it wasn't going to work. It was going to cause issues, block lasers. We'd have to cut through. Aesthetically, it would just kind of look like crap. This was making it work in a way that also fits with the overall design of the overall project. So that's kind of the key, right? I forgot a feature, didn't just, you know, cash it in and slap it on there. I made the feature the way that I wanted it to be. Now, admittedly, it's not exactly the way I wanted it to be. That has to do with the fact that I'm not exactly sure how I would model it to be exactly the way I want it to be. I don't know how, right? I'm not sure. But it's pretty close to what I had in my head when I started it. So I didn't just, the key is I didn't shortcut it, right? I went for what I was shooting for. So that's kind of the key takeaway there. So I hope this was at least a little informational. I hope it was at least a little entertaining. I hope it wasn't too awkward watching me squirm, realizing I forgot a key feature. And I look forward to seeing you back next week, when hopefully we will actually wrap this design up. And then I, you know, get to stress over what we do for the next series. So, again, thanks for watching. If you've made it, you know, almost 2.5 hours tonight, I really appreciate it. And from the future, hi, drop a comment.